All right, welcome back. Last time we were here, we figured out how to build and even animate layouts using awesome tools like Flexbox and Grid. But now we're going to make those layouts smart. We're about to dive into making our designs responsive, scalable, and yeah, truly dynamic. Look, building a layout that looks perfect on your own monitor, that's a great start. But what happens when that design ends up on a tiny phone screen or a massive widescreen TV? The real challenge for any modern developer isn't just about building one design. It's about creating a single, intelligent design that just works and looks amazing everywhere. So we've already got the skills to structure our pages and bring them to life with some cool animations. Now it's time to level up. We're going to give those layouts a brain and teach them how to adapt to any environment they find themselves in. This is a really crucial step on your developer journey. So here's the big challenge, right? We have one code base, but there are countless devices out there. How do we make our website look just as fantastic on a phone in your pocket as it does on a huge desktop monitor, all at the same time?
Well, the solution is a whole philosophy called responsive design. The idea is simple. Instead of building rigid, fixed-width layouts that just break on different screens, we build fluid, flexible systems that gracefully adapt to pretty much any screen size you throw at them.
Let's start with the classic approach. Our first tool is really the absolute cornerstone of responsive design. It works by looking at the big picture, the entire browser window, or what we call the viewport. And that tool is the media query. Honestly, the best way to think about it is like your CSS is asking the browser questions. It can ask, hey browser, are you wider than say 800 pixels? Or is this a phone being held sideways in landscape mode? If the browser answers yes, boom, a specific set of styles gets applied. Now, when you're using media queries, you've got two main strategies. There's desktop first, where you start with the big, full-featured design and then kind of strip things away for smaller screens. But the modern best practice is definitely mobile first. With this, you start with the essential core experience for a small screen, and then you use min width to progressively add more features and complexity as the screen gets bigger. It really forces you to prioritize what's most important.
Let's make this real with an example. Imagine on a phone, we want a bunch of cards to stack up neatly in one single column. But on a larger screen, like a tablet or a desktop, we want those same cards to sit side by side in a nice two-column grid.
And here's exactly how we pull that off. By default, our container is just a single column grid. Super simple. But that app media rule creates what we call a breakpoint. It's a trigger that tells the browser, hey, if the viewport is at least 768 pixels wide, then forget the default and switch to a two-column grid. It's an incredibly simple yet powerful way to control our layout. But media queries do have one big limitation. They only care about the size of the entire viewport. So what happens when you have the exact same component, but one is in a wide main content area and the other is squeezed into a narrow sidebar? On a big screen, the media query would treat them both the same, even though one has way less space to work with.
This exact problem led to a major evolution in CSS. I mean, a true paradigm shift in how we build websites. It's a way for components to respond not to the whole page, but to their own personal space.
The difference here is fundamental. A media query asks, is the whole room wide? But a container query lets a component ask, is my personal space wide? This is an absolute game changer for building truly reusable, modular components that can adapt no matter where you drop them. And it's a really simple two-step process. First, you tell the browser which element you want it to watch by making it a containment context. Then you write an @container rule, which works just like a media query, but it targets that specific container's size instead of the whole viewport. So here's what that looks like in action. We've defined our .post element as a container. Now, that @container rule says that whenever that specific container gets wider than 400 pixels, the card inside it should switch to a horizontal flex layout. This is exactly what we mean by self-aware components. It's a huge leap forward for modular design.
Okay, so our layouts are now adaptive and intelligent. That's awesome. But what about our actual styles? You know, if you're using the same brand color or font size in dozens of places across a huge project, changing it can be a total maintenance nightmare. We need a better way to manage our styles at scale.
And that's where CSS variables, or more officially, custom properties, come into play. They let you store values, like colors, spacing, font sizes, in one central spot. This creates a single source of truth for your entire design system, which is just fantastic for consistency. So here's how they work. We define our variables, and they always start with 2 dashes inside this special .root selector. Think of .root as the highest level of your whole document. That makes them globally available everywhere. Then, anytime you need that value, you just use the var function. Now, if you need to update your brand color, you only have to change it in one single line of code. It's so much easier. And these variables are incredibly flexible. You can define them globally, like we just saw, or you can scope them locally to just one component to override the defaults. And this is the really cool part. Because they're part of the live web page, you can actually change them with JavaScript. This is the magic behind how modern light and dark mode theme toggles work. But modern CSS can do way more than just store values. It can also calculate them on the fly. It's like having a powerful built-in calculator right inside your style sheet. We've got a whole suite of math functions at our fingertips. Calc lets you mix different units, like subtracting pixels from a percentage. Min and max let you set dynamic boundaries. But the real star of the show for fluid responsive design is definitely clamp function. The clamp function is awesome. It takes 3 values, a minimum, a preferred value, and a maximum. In this example, we're telling the H1's font size to try to be 4% of the viewport's width, but it should never go smaller than 1.5 rem and never get any larger than 3 rem. This single line of code creates beautifully fluid text with built-in safety rails. No more tiny text on mobile or giant text on desktops. And that brings us to our next checkpoint on the roadmap. We've just covered a ton of ground, learning how to create layouts and styles that can actually think, scale, and adapt to their environment. You now have the essential toolkit for modern front-end development. You can build page-level responsive layouts with media queries, create self-aware components with container queries, and write truly maintainable, dynamic styles with variables and functions. This is powerful stuff. So what's next? Well, in our final explainer on CSS, we're going to dive into how to use all these powerful features like a pro. We'll cover professional best practices, accessibility, performance, and the whole ecosystem of tools that power modern CSS development. This is Developer Roadmaps. Map your path, build your career.